Hello, guys. So we begin our introductory lesson to botany. Do you like touching plants, looking at plants, smelling plants, eating plants? Some of you do, I can tell. I do too. I like all kinds of plants. I like plants with fuzzy leaves, and I like plants with funny faces like these ones. I like plants that look like stones and plants that taste so good. How do you call people who grow plants? How do you call them? Who knows? Huh? Anyone? Anyone? People who grow plants for us to eat. How do we call them? Vanya, do you know? Lilia?
Farmers.
Farmers. Yes, we call them farmers. Well, we can call them gardeners too. If you have a little garden in your backyard, you grow food, you are a gardener. If you grow a lot of food to sell, then you are probably a farmer. But how do you call people who study plants? Do you know? Diana?
Botanists.
Botanists, that's right. Botany is the study of plants. You may have heard another word, biology. Have you heard the word biology? Yes. Do you know the difference between botany and biology? Biology is the study of all forms of life. Birds and fishes, all kinds of land animals and bugs and mushrooms, everything. And botany is a part of biology that works with plants only. So we will be talking about botany. That is why we are talking just about plants. So if you love bugs, if you love sharks and maybe tigers, you're out of luck today, but you will have to watch my other lessons for that. Botany. Botanists study plants that can become medications and can treat diseases, all kinds of diseases. Have you ever heard of a disease called scurvy? I know two girls here that certainly do. Diana and Iliana know a little bit about scurvy. What is it? Can you tell me? No? You prefer me to tell the story? Okay. Well, 200 years ago, scurvy was very common. Many people got sick with scurvy, especially sailors and explorers. But a doctor once found out that if you give people lemon juice or lime juice, that would prevent scurvy. So ships began carrying barrels of lime on them, and sailors began drinking lime juice. That was too sour for them. They didn't really like it, but they noticed that they don't get sick with that dreaded disease. And that disease was no fun. Your gums would get painful and red and inflamed, and then your teeth would fall out. And you would have sores all over your body, and you would feel weak, and you could die. So eating lemons and limes certainly helped with that. Not only sailors, but also explorers who tried to get to the North Pole first and explore the frozen regions of the earth, they also got this disease. Eventually, people found out it was the vitamin C in these fruits that helped prevent scurvy. Scurvy is a disease that which you get when you don't have enough vitamin C in your food. So botanists that study plants can help people get well or prevent diseases. Other botanists experiment with plants to learn more about them. Maybe they can find a way to grow the sweetest apple in the world, or maybe roses that don't get sick. Do you like roses? Do you like these flowers? I love roses. I planted 5 roses and all of them got sick because roses easily get sick. So I'm always looking for plants that don't get sick. And that's what scientists are looking into as well, how to grow healthier plants that can handle heat and rain and all kinds of difficult conditions. So that's nice. Do you think you can grow plants in space? No. Well, there are some scientists who grow plants inside space stations, that is, in space. These botanists are called astrobiologists, like astronauts, astrobiologists. Experimenting with plants is exciting even if you aren't in a spaceship, even if it's your own backyard. Another thing botanists do, okay, let me go back on the screen. Here we go. And I'll make myself bigger. Another thing botanists do is they organize things. Well, which one of you likes organizing things? I know some kids, their bedrooms look like there was a dump truck there, just dumped a lot of stuff. You open their closets and everything falls out. Do you have a closet like that? Well, you don't have to raise your hand. And I know some kids, they love organizing things. They like to be neat and everything is lined up just so. Do we have any kids who like organizing things and sorting them out? Ooh, so we have some of them. All right, if you like organizing things and you like plants, well, maybe you would be interested in taxonomy. What is taxonomy? That doesn't sound very exciting, does it? It's not like spaceship or something. Taxonomy. Diana.
It's like groups that go from big to and get separated.
Yes, very good. In other words, taxonomy is organizing plants, not just plants, but life in general, birds and bugs and fishes, but we'll be talking about plants and plant taxonomy. So what is it? Have you ever been to Walmart? Have you? Or any other big store? Yeah, I've been to Walmart as well. Well, when you walk into the store, how many things do you think are sold there? 10, 100, 1,000, maybe a million? What do you think? How many? Lila.
Like 10 million.
Maybe 10 million. Many things are sold at a store like that. What if we dumped them all together? Would you be able to find what you want? You walk in, you want a skirt or a swimsuit or a baseball hat. Would you be able to find anything? No. What if all things were neatly stacked on the shelves? Milk jugs next to cleaning supplies, next to bowls, next to books, next to clothes. Would that be easy to find something you want? If on the same shelf you have a milk jug and then a cleaning supply, a cleaning solution, and then a notebook, and then a bowl, and the whole store is like that. Everything is neatly on the shelves, but everything is mixed up. Would you know where to get milk? No, you wouldn't, right? Even though it's all lined up, it's not grouped together. Why do we quickly find things in the stores? Because we know that toys are kept all together. Bikes with bikes, balls with balls, dolls with dolls, right? And if you want to buy milk, you don't go into the clothing section or the toys section. You go to the produce aisle, right? And you know exactly where to find milk. It's in the fridge. And milk is next to half and half and cream. So everything is sorted and separated. And that's exactly what botanists do. They sort plants into different categories, big and small. So they look at plants and they call it kingdom plantae, that is kingdom of plants. They look at what is similar and what is different. And they say, okay, these guys have seeds. They go this way. And those don't have seeds, so they go that way. These are two separate groups. Now let's look at the group with seeds. That's surely a big, big group. What do we see? Some of them have flowers. And some of them don't have flowers. Okay, let's separate them again. Now let's look at those who have flowers. They have different kinds of flowers, okay? You guys with these flowers go here, with those flowers go there, and they keep separating and separating until we get to very, very small groups, and that's called taxonomy. It all began, you wouldn't believe it, this whole taxonomy thing began with a little boy who was named Carl Linnaeus. And this boy lived in a country almost on the very top of the world, the country called Sweden. So what was his life like? I'll tell you a little bit about Carl Linnaeus, and if you're curious about him, I will tell you where you can read a little more. There is a fun book about him, but actually this is the book. You can see it right away. Well, when Carl Linnaeus was just a baby and he would cry, his parents distracted him with a flower. When he just learned to walk, he walked straight into his father's garden, and he kept pestering his father with questions about plants. He wanted to know every plant's name and what that plant does. Well, when he grew up when he grew a little older and he went to school, what do you think? He loved school or hated school? Maybe this, maybe that. Well, if you think he loved school, thumb up. If you think he hated school, thumb down. Okay, some of you think this. Well, he hated school. Back then, every school had Greek and Latin classes, old languages that people didn't speak anymore, but they were the languages of the smart books. So if you wanted to read scientific books, smart books, you had to know Greek and Latin. Those were also languages of the church, as some churches kept their services in Latin for the longest time. So if you didn't understand that, you couldn't be a leader in the church. So children had to study those languages, but many children didn't really like it. So neither did Carl. He hated hours and hours that he had to spend with his books, and he took any chance to slip out into the garden and study plants and bugs. He liked plants and he liked bugs. Well, after a while, do you think his teachers were happy with him? Yes or no? No, teachers are never happy with children who hate school and don't do their homework, do they? All right, so his teacher told his parents that this boy was stupid and good for nothing. And his parents hoped that he would be a lawyer, maybe, or a great scientist, or maybe a clergyman in a big fancy church in a big city. But now they're told he is stupid, can't do his homework, and he's good for nothing. So his father was very upset and decided to apprentice the boy to a shoemaker, so he would learn the shoemaker's trade. Well, good thing this shoemaker was an observant, kind, and smart person. He noticed how this boy loved the plants, and the plants were used for medicine in those days. It was actually the only medicine that people could get. So he talked to the boy's father and said, hey, why don't you teach him to be a doctor? Why don't you send him to a school that makes doctors? Well, that was a good idea, and the boy loved the idea, but his parents didn't have enough money. They were a poor family, and to become a doctor, you needed to spend a lot. Guess what? Carl got into school anyway, but since he didn't have a lot of money, he had to go hungry a lot of time. He had to skip a lot of meals. Often he was happy to have one meal a day, Well, that doesn't help studying a lot, but he studied hard, even though he was so poor. That gave him a lot of new things to learn, lots of ideas. But there was one big problem. What do you think that was when you study plants? Gardeners and farmers and doctors all had different names for plants. Some plants had 3 names, other plants had 10 names, still other plants had 30 to 40 different names. Well, how can you make sense of it? If someone tells you this plant can help with heart disease and names a plant, and you don't know what it is, or maybe you know, maybe this plant grows in your garden, but you call it differently. So if you can't agree on a plant's name, how can you treat people? How can you study plant? Do you know this plant's name with fuzzy leaves? These leaves look like lamb's ears, and so they are called lamb's ears by some people. Well, other people call them woolly hedge nettle. Still other people call them Stachys byzantina. Well, how can you agree on anything? Scientists of Carl's day liked long, fancy Greek and Latin names for plants, but even they could not agree with each other how to name a plant. That was a mess. And Carl decided to clean this mess up. Even though he was young, even though it was a huge job with tens of thousands of plants in the world, he got right to it. He was the first taxonomist. He created the system of big groups and smaller groups and yet smaller groups. And he also decided to give plants simple names, either in Latin or Greek, those languages that scientists understood and people in all countries understood, whether they spoke French or German or Swedish or English, everybody knew Greek and Latin. Moreover, since people didn't speak these languages, those were the languages of the books, the languages didn't change, so these names would stay the same forever. He called it binomial classification. Binomial means to name. Binomial, to name. For example, Stachys byzantina, the scientific name of that fuzzy plant, has 2 parts, Stachys and byzantina. Each part describes the plant from different sides. So Carl started naming plants, and he never ran out of ideas. He kept naming and naming and naming. Well, I won't tell you the whole story of Carl Linnaeus. You can read that in the book, but I'll tell you what. After he was finished, other scientists picked that up. Well, first they didn't. They thought he was foolish and this whole business was crazy. But later on, they admitted that that was a good idea. And they kept working on his system and changing it. And they are still changing it. Quite recently, scientists again changed some of these big boxes, these divisions of plants. So they fine-tune the system so it works better and better. Now, we'll do just the simplest things, the basics today. All plants together are called kingdoms, as I said before, even though they don't have a king or a queen. The next biggest group is called phyla. Each one of them is called phylum, but together, plural is phyla. You can see just a few phyla here: mosses, liverworts, ferns, gymnosperms, angiosperms, but there are more. There are 14 in all. Today, I will tell you about 2 major differences between plants. Ready for that? Okay, let's study vascular and non-vascular. Well, I know that doesn't sound exciting. Those are big, hard words, but there is always a way to make things simpler. Let me do it for you. Some plants simply have tubes and others don't. Those that have tubes are called vascular plants, which, if you translate that words into English, would mean tube plants, plants with tubes. Do you know that you have tubes in your body as well? Do you know, have you ever found tubes in your body? Yeah, what do we call them? Diana.
Veins.
We call them veins. Yes, veins and arteries. Can you find veins on your body? Raise your arms and look over here, and you will find blue lines, thin or thick. These are veins, maybe here on this side. Yes, maybe you went to a doctor and some blood was drawn from your vein over here. Or on this side of your hand, especially in older people, if you have a grandma and a grandpa, their veins usually bulge out and you can see them very well. So that's the tubes human bodies have. Tubes are for carrying liquids. You know how we use sippy cups with straws to draw in liquids. Now, what do our veins carry? What do veins carry? Anyone? What's inside? Yes, Ivan, Vanchika.
Blood.
Blood, yes, they carry blood. Did you ever cut yourself? Did you ever cut your finger or something? What happened then? Vanya, what happened?
Blood was going out of the finger.
Well, yeah, when you cut yourself, then blood flows. You have blood. Because your tube was cut and the liquid got out. What happens if you break the plant's stem? Well, there will be some sap coming out, either white or maybe orange like this, or maybe some other color. Now, do you have a leaf with you? Did anyone bring? Okay, now it's time to get out your leaf and look at it closely. Okay, do you see tubes in your leaves? Do you see? Yes. I see some of you showing, right. On this picture, on this photograph, you can see a leaf of a plant called elephant's ear. And this plant has very distinct veins. You can see them so well. They are even a different color from the rest of the leaf. And you girls, Yana, Iliana, yes, you have leaves. I see that Ivan has leaves and Lilia too. So you can look at them and see they're different on different leaves, but yes, you certainly can see those tubes. They carry liquid, they carry sap within the plant. The sap is a liquid, water, with some chemicals in it, some pigments that give it color. Some have sugar in it, like sugar cane. So when you suck on sugar cane, it's sweet. Or if you lick sugar maple's wood, the sap will be sweet. But some plants have poisons in them. If you lick those plants, that's not going to be good. That's probably gonna taste bitter and you can get very sick or die. So don't chew on plants that you know nothing about. If you eat celery, do you guys like celery? No, I know many kids don't like celery. Okay, some of my kids don't and some of them do. I didn't like celery at first and then I got used to it. But if you break the stem and then pull, you know what happens? It's kind of tough and you see those strings, those fibers. In a celery stalk, you can easily see those tubes because they're big and tough. Yes, Diana.
Once we did an experiment and put it colored water and it became blue.
Into a glass of water until it's very bright, and then put a celery stick inside, and then go and check on it after 3 hours, better yet, the next day. And you will see this colorful liquid traveling up the tubes, and those tubes will be colored a different color and will really stand out. But if you take a stalk with leaves still attached, the leaves will change their color. That is even cooler. Watch it for a day or two. Better yet, have 3 cups or 4 with different colors and put celery sticks in those and see what happens next. Well, not just celery sticks and leaves have veins, but flowers do too. And some are very pretty and easy to observe, as this orchid flower. So botanists discovered that most plants they study have these very helpful tubes called veins to carry liquids inside plants. In fact, if a plant has roots, stems, and leaves, it is a vascular plant. Now, how can we have a plant that doesn't have stems, roots, or leaves? What would that look like? I'm not gonna show you. Use your imagination. I see Liana has an orchid plant, so she has a live flower with veins, but now think of a plant without leaves, without stems, without roots. We call those weird plants non-vascular, no tube plant. You know what it is? 1, 2, 3, go. Diana, Iliana, what are those?
Moss.
Mosses. Good job. Mosses, when you look closer at them, and I encourage you after this lesson to grab a magnifying glass, go outside and find moss where it grows, and then study it. Moss likes wet places where the water is dripping or there is shade, so the soil stays moist, and that's where mosses grow. Go and study them. And then you'll see that they do have something like a root, something like a stem, and something like leaves. But if you study these roots and stems and leaves, you will see that they are different and they have no tubes. So scientists say that these are not true stems, leaves, and roots, but a kind of false roots and stems. Moss can grow on the ground, on rocks, on trees, and even on buildings. Well, how do they carry liquids if they have no tubes, huh? How do they get moisture? Who knows? Do you have any idea? No? Iliana, what do you think? Your mic is off, Iliana.
They soak up the water.
Yes, they soak up water. Do you have paper towels at home? Yes, you know how paper towels and napkins behave? What if you dripped some milk or water on the paper towel or juice? What happens, Yana? What will happen?
It gets all wet.
It gets all wet, or maybe not all. If you dripped a little, it gets wet where you dripped, right? But that spot kind of grows, and then stops. If you poured half a glass of milk, then the whole thing will be dripping wet. But if you dripped maybe 1 teaspoon, then the spot grows, and then stops. What happens? The towel absorbs the liquid, kind of lets it spread a little bit. And that's how mosses get their moisture. That is why they grow only where there is a lot of humidity, where there's a lot of water in the ground or in the air. Do you know that sometimes there's a lot of water in the air? Like after a shower, after a nice rain, there's a lot of moisture in the air. That's where mosses like to grow. And that's why you will find tons of mosses, different kinds of mosses in jungles, in those parts of the world where there is a lot of moisture, but you won't find too many in the deserts. Even though after the rain in the desert, mosses will recover and be green and nice, but then they will dry up and just sit tight and wait for another rain. If plants can do without tubes, then why most plants have tubes? What do you think? If they could just absorb water from the air, why do they need tubes? Vanya, do you have any idea? That's a thinking question. That's not so easy. Well, yes, Vanya, try. Okay, you probably try to turn your mic. Yes?
Yep.
Mhm.
Because the moss don't have tubes, so it can't gather the water from the ground.
Yeah, you can't gather water from the ground. So if the top of the ground or the rock dries up, the moss dries up as well. Unlike grasses and trees that can send their roots deep down into the earth and draw water from there, mosses can do that. They just shrivel up and die or remain dry and shriveled up and just waiting for another rain. So mosses cannot live everywhere. They can live only in certain places, and they can't grow very big, can they? They stay short, they stay little, unlike trees and some grasses that can grow very, very tall. So that's the end of our lesson. As I said before, I encourage you to go outside, find mosses, get a magnifying glass, and draw what you see. And you can send me your drawings. I will be happy to look at them. Well, and if you decide to continue with my classes, we will talk about other fun things, grasses that grow as tall as trees, plants that can shine in the darkness, and plants that feed us and clothe us, and even mushrooms that can be turned into bricks and packaging. So I will be glad to see you at my botany lessons starting this September. Now enjoy yourselves and go study your plants. Bye-bye.
Пока.
Пока.
Пока. Bye-bye.
Sonia.